Hi, this is checkpoint 2.10 from section 2.2. They want us to find the volume of the solid of revolution formed by revolving the region bounded by the graphs of y is equal to square root of x and y is equal to 1 over x over the interval from 1 to 3 around the x-axis. If this is our region, if we put x is equal to 1 for both of these, you're going to get the same y value. So 1 is where they intersect, and 3 would just be somewhere over here. And so this in here is going to be the volume, or the area, the region that we're looking for that we're going to rotate. Let me recreate this drawing. Try to use the same colors. We have this thing. We have this thing. Now, what we're going to do is we're going to revolve this around the x-axis. So as you revolve around the x-axis, we are looking at a mirror image below the x-axis. All right, so that's the mirror image, and we're going to cut it off here. And as we do the rotation, we're going to create this region. So we kind of don't need this part. Let's take that off. And then we'll do the rotation. So it looks like it's going to give us a shape of something with a hole in it. And whenever there's a hole in it, we think about doing a washer. Now, how is this washer going to look like? If we make our cut straight down here, we're going to get a circle with a hole in it, and give it a little thickness, it becomes a washer. All right, let's draw this out. That's your big circle, a little circle with a hole in it. To find the area of this washer, area is going to be the area of the big circle. Let's call this R out for the outer radius, and that would be measurement from the center of rotation to the largest part, minus the area of the circle pi r, and let's call this n to be r in to be the radius of the smaller circle. Now we need to find those in this original picture. And if we think about r out, just think about that as going from the axis of rotation. So your center point is always going to be the axis of rotation. And the axis of rotation in this case is the x-axis. And you're going to go from the x-axis all the way to the farthest part of your region. And that hits the function y is equal to square root of x. So it gets a y value, and y is equal to square root of x. So it looks like we're going to eventually want to write our a as a function of x. And so that's pi times r out. Oh, these are squared because it's pi r squared. Okay, so r out is square root of x. Put that in r out squared, square root of x squared. Let's just put square root of x for now, and then squared. And now r in is going to go from the axis of rotation to the edge, the closest edge of the region, which is going to be r in is going to be 1 over x. So that's going to be 1 over x squared. So this is going to be our integral. Our thickness is going along the x-axis, so that's delta x. And that is going to change our Riemann sum into an integral with a dx. All right. So let's go ahead and write our integral. Our volume is going to be the integral from 1 to 3. Those are our limits of integration. We have a pi. We actually have a pi for both of them, so we can factor that out. And the first one is just going to be an x. The second one is going to be 1 over x squared, which we probably should have rewritten. We'll rewrite it as an x to the negative 2. So we'll take the pi out, integrate from 1 to 3, x minus x to the negative 2 power dx. So that would give us an integral of 1/2. We'll put the pi in here first, the 1/2 x squared. And here, this is going to be an x to the negative 1 divided by negative 1. So x to the negative 1 divided by negative 1, that makes that a plus 1 over x. We're going to integrate from 1 to 3. Couple more steps. We have x squared over 2 plus 1 over x, evaluated from 1 to 3. So we'll put a 3 in there. We're going to get 9/2 minus 1/3 minus, and then we have, oops, this is a plus 1/3, and we'll put 1 here. We get a 1/2 plus 1. What are we going to get? 9 minus 1 is 8. 8 over 2 is 4. And then we have a 3 minus 1. So that's 3 minus, that's 1 minus 3. So that would be a negative 2, negative 2/3. Common denominator of 12. Nope, common denominator of 3, so this would be 12 minus 2, that's 10 over 3 times pi. All right. Okay, hope that helps.